A second measure of spread is called standard deviation. And this is approximately the average distance each data item is from the group. The key here is it's measuring each data item. So range only measured the largest and the smallest, where standard deviation is looking at every item in the list and measuring that distance, so you get a little bit more information than you did range. So basically, it's the spread of the data, which we kind of have already been saying. So let's go ahead and look at example 2. The numbers 3 and 5 have a group average, or just an average, of 4. Makes sense, it's in the middle. So they're both 1 unit away from the number 4. That means that if we were to calculate their population standard deviation, we would get 1, because both of their distances are 1 and the average of ones is 1. So it's just using the formula. Now, what about some of these other problems? Question 3. Which set of data would have the larger standard deviation? Now, a lot of people get this one wrong. They think that because the second set of data has bigger numbers, it will have a bigger standard deviation. And that's not necessarily true. The mean would be larger from a larger set of numbers, but not necessarily the standard deviation. So as you look at the two groups, maybe even pause and think about it. When you try to decide who's going to have the larger standard deviation, first look at the range. So for the first set, you get 11. The range for the second set, 5. So if we're trying to find a larger standard deviation and it's how far every number is away from the mean, then what's going to happen is your answer is going to be the first set. The numbers are spread so much further away from each other that their standard deviation will be greater than the second set. What about question 4? It asks, why can the standard deviation never be negative? We've actually already mentioned that one. It measures distance, and distance is never negative. And as we will later see in the formula, it couldn't be negative also. So now consider question 5. Standard deviation can never be greater than the range. Maybe you want to pause and think about it. The reason that the standard deviation is never going to be bigger than the range, it measures to the mean, the center, not the furthest number. And if you think about it, that's what the range does, takes the smallest and finds the furthest away number, whereas here we're only measuring to the center. And then what about question 6? In question 6, we're given a set of 4 numbers, 13, 14, 14, and 15, and asked which standard deviation makes sense. Now, right away you should throw out the negative one. The 14 seems a little large, but 14 is the mean, but we're asked for the standard deviation. So in this case, again, if we look at the range, then, 15 minus 13 gives us a range of 2, and we just mentioned the standard deviation would never be bigger than the range, so never in this case bigger than 2. So we get to knock 14 and 4 out. So a standard deviation of 1 is the most logical answer, and the true standard deviation in this case was 0.82. So we're actually much closer with number D, or letter D.